Welcome to Problems and Solutions. Today we'll solve problem 23 of chapter 21 of Fundamentals of Physics. In the figure, particles 1 and 2 of charge Q1 and Q2 are on the y-axis at a distance d from the origin. Particle 3 of charge Q3 is moving gradually along the x-axis from 0 to x equals 5 meters. At what values of x will the magnitude of electrostatic force on the third particle from the other two particles be A, minimum, and B, maximum? What are the minimum and maximum magnitudes? Okay. First, you notice that I didn't mention the numerical values because I won't use these numerical values. I will solve the problem and let you to use these numerical values. I won't solve with Q1 and Q2 and D and X. Okay, first let's consider the direction of the forces. The electrostatic force will be in the direction of the line joining the forces. So here we have, let's do it again. Here, a line join 1 and 3 and 2 and 3. So the force will be in these directions. The force here of particle 1 acting on particle 3, and here we have the force, the particle 3 acting on particle 3, 2 and 3. Okay, here we have the force, and we know that magnitude of the force will depend of the product of the charges and will be inversely proportional to the squared distance between the charges. So we have here F1 and F2. And the magnitude of this force will be 1 divided by 4 pi epsilon 0, the product of the charges, divided by the distance squared. In this case we have d and x, so here we will have d squared plus x squared. Here we have, of course, d squared plus x squared, this distance. Okay, and the force acting on particle 3 will be only in the horizontal direction, because the force in the vertical direction will cancel each other. The projection in the vertical direction, here we have the projection of F2, and here we have the projection of F1, and this force will cancel each other, so it's not necessary to consider this force in the vertical direction, only in the horizontal direction. That is, the force acting on particle 3, it will be in the x direction, and it will be the projection of F1 in the horizontal direction plus the projection of F2 in the horizontal direction also. So we will have this projection, of course, will be equal. No? It will be equal because the magnitude of the force are equal. So here we have let's say an angle theta, and here we have the same angle theta. So we will have fx equals this force, but we'll sum two equal force, so here we have 2 instead of 4, summing two equal forces, and both will be multiplied by cosine of theta, because we are projecting the force in the x direction. Here we have to consider that the force in this case are written using two variables, theta and x, and we must choose which variable we want to work with. In some cases, especially in electrostatic problems, it's convenient to work with an angle instead of a magnitude, a coordinate. And in this case, we work with the angle theta. We'll solve the problem using the angle theta, and then we'll return and write the angle as a function of the x variable. So to work with an angle theta, we'll notice that the sine of theta equals d divided by square root of d squared plus x squared. Here we have d squared plus x squared. Therefore, we can write that 1 divided by d squared plus x squared equals sine squared of theta divided by d squared. I take the square here of both sides of the equation, and I divide both sides of the equation by d. So you arrive at this equation. So using this, we can write that fx equals 1 divided by 2 pi epsilon 0 d squared. Here we can write key 1, key 3, and we will have sine, here, sine, using sine, not sine, sine square of theta multiplied by cosine of theta. And we want to find the maximum of this equation. So let's start here. As I already mentioned, the vertical component of the force will cancel each other. So the minimum value of the force here is not necessary to do nothing. It's only to look at the problem. We know the minimum value. It will occurs when x equals to 0. X equals to 0, meaning that the charge 3 will be here, and we won't have any horizontal component, and the vertical component will cancel each other. Therefore, here we have f equals to 0. It's simple to see. We can find use theta equals to 0 here, and you know that fx will be 0. So it's a consequence of this equation also, but it's not necessary to have this equation to find that when we are here, the charge 3 are here, the force will be 0. It's a consequence of the symmetry of the problem also. But we can look at this equation also to confirm this. When theta equals to 0, we have here 0, here 1, and this will be 0. Item B, to find the maximum, it's necessary to derive this force. So let's do it. It's necessary to find the maximum, to derive with theta. So to derive here. So we'll have, of course, this is only a multiplication factor, so here it won't change, and it's necessary to derive this equation. So it's a product. So deriving the first, so 2 sine of theta, chain rule. So cosine of theta is squared, plus the first term, sine of theta, deriving the cosine, minus sine of theta. Okay, I think it's correct. And this equals to 0 to find the maximum. Therefore, we will have 2 sine of theta cosine square of theta equals sine square of theta sine of theta, and this cancel. And we can also take the square root of both sides of the equation. So we have 2 square root of 2 multiplied by cosine of theta equals sine of theta. Therefore, sine divided by cosine, that is the tangent of theta, equals square root of 2. Returning to the problem, the tangent will be the d divided by x. So d divided by x equals square root of 2. Therefore, the value of x that will cause the maximum in the force will be equals d divided by square root of 2. For today, that's all.